You were fine a minute ago. The lights were on. The room was familiar. Everything was exactly where it had always been. Then the lights went out, and something changed. Not in the room. In you. Not panic. Not immediate fear. Something quieter than that. A shift in your body's baseline. A slight increase in alertness. A subtle recalibration of attention away from whatever you were thinking about, toward the edges of the room. The corners. The doorway. You couldn't see anything threatening. That was exactly the problem. And your brain, 300,000 years old, built for a world you no longer live in, responded to that absence of information the only way it knows how. It assumed the worst. What happens inside the human brain when the lights go out is not a malfunction. It is not a childhood leftover that adults should have outgrown. It is one of the most sophisticated survival systems ever produced by evolution, running at full capacity, right now, in you. And the story of why it exists, and why it's still running in a world of electric light and locked doors, is the story of what made humans human in the first place. By the end of this, you'll understand your fear of the dark differently, not as something to overcome, as something to understand. And what you understand about it will tell you something about yourself that goes much deeper than fear. There's one specific thing that happened to our ancestors at night, documented in the fossil record, that explains not just the fear, but the brain you have right now. We'll get there. Start with a night 200,000 years ago. No fire. Or maybe a small one, barely enough to hold the circle of darkness back a few feet. A group of early Homo sapiens on the East African savanna. Sitting. Listening. Not to each other. To everything else. In daylight, a human being in that environment is a capable animal. Upright posture gives height and range of vision. Binocular vision with excellent color discrimination allows detection of movement and threat at distance. The ability to throw projectiles accurately gives defensive reach that most predators lack. In daylight, the human sensory system is well calibrated for that environment. At night, almost none of those advantages hold. Human night vision is poor compared to the predators that shared that landscape. Lions, leopards, hyenas, crocodiles near water sources. In darkness, the visual advantage disappears entirely. The human standing at the edge of firelight cannot see what is 20 feet beyond it. But what is 20 feet beyond it can see them. This was the reality of human life for almost the entirety of our species' existence. Every night, for hundreds of thousands of years, not the occasional threat, the nightly condition, and the brains that survived, the ones that produced offspring, that passed their architecture forward into the next generation, were not the brains that were comfortable in the dark. They were the brains that were constitutionally, automatically, reflexively uncomfortable in the dark. Your fear of the dark is not a weakness your ancestors would have helped you overcome. It was the trait that let them become your ancestors. The specific brain system responsible for fear of the dark has a name. It's called the amygdala. And its relationship with darkness is more precise than most people understand. The amygdala is an almond-shaped structure deep in the temporal lobe, one on each side of the brain. Its primary function is threat detection and fear response coordination. It processes sensory information and flags potential dangers before the conscious mind has time to evaluate them. This is important. The amygdala responds before you think. By the time you're consciously aware that something made you uneasy, the amygdala has already been running its assessment for hundreds of milliseconds. It has already begun preparing your body, elevating heart rate, sharpening focus, priming muscles for movement. You experience the result as a feeling. The process happened before you arrived. And here is what the research shows about the amygdala and darkness specifically. A 2005 study from the Weizmann Institute of Science in Israel found that the amygdala shows significantly elevated activity in darkness, even in the complete absence of any threatening stimulus. not in response to something scary in the dark, in response to the dark itself. The darkness is the trigger, not what's in it, because what's in it is unknown, and to the amygdala, unknown is not neutral. Unknown is dangerous until proven otherwise. This is called the negativity bias in threat assessment. When information is ambiguous or absent, the brain does not default to neutral. It defaults to threat. In evolutionary terms, this makes sense. The cost of assuming threat when there is none is mild. You were briefly afraid for no reason. The cost of assuming safety when threat exists is potentially fatal. You didn't run when you should have. The brain that survived was the brain that erred toward fear. And that brain is yours. But here's the layer of this that goes deeper than simple threat detection. The fear of the dark is not just about predators. It's about something more specific that the fossil record reveals. Something that happened to human ancestors at night that shaped not just their fear responses, but the entire architecture of their social lives. In 2018, a team of anthropologists led by David Sampson at the University of Toronto published research on what they called the nocturnal bottleneck in human evolution. The argument was this: for millions of years, the primate lineage that led to humans was diurnal, active during the day, sheltered at night. Night was a period of vulnerability and rest. The brain during that time was largely offline. But Homo sapiens, at some point in their evolutionary history, didn't just survive the night. They began to use it. Fire changed everything. With fire, small groups of humans could maintain a lit space after dark. And in that lit space, protected from the predators that owned the night, something happened that had never happened before in primate history. Humans began to talk. Not the functional communication of the day, warnings, coordination, task organization. Something different. The research on what early humans likely discussed around nighttime fires, based on studies of contemporary hunter-gatherer groups, suggests that nighttime conversation was predominantly social. Stories, relationships, moral questions, the behavior of absent group members. In other words, the things that required not just communication, but reflection. Theory of mind, the ability to represent other people's mental states and discuss them. The anthropologists' argument was that the cognitive expansion that made humans uniquely human, the development of complex language, social reasoning, moral thinking, long-term planning, happened largely in the context of nighttime fire. The dark outside the fire circle was not just a threat. It was the condition that drove humans inside the circle, and inside the circle, human consciousness evolved. Your fear of the dark and your capacity for complex thought are not separate phenomena. They grew from the same evolutionary moment. The darkness outside the fire created the pressure. The fire created the space. And in that space, the human mind became what it is. Now let's talk about what actually happens in your brain when you're alone in the dark, because the experience is more specific than just fear. There are layers, and each layer has a distinct neurological signature. The first thing that happens is attentional reorientation. Within seconds of significant light reduction, your brain shifts its attentional resources away from internal processing, the thoughts, plans, and memories you were engaged with, and redirects them outward, toward sensory input, toward the environment. This is controlled by a network called the dorsal attention system, and it happens automatically, not because you decided to pay more attention, but because your brain detected an information gap and responded by allocating more resources to filling it. You stop thinking about what you were thinking about. You start listening. The second thing that happens is an elevation in threat monitoring activity in the amygdala, which we've already covered. But the third thing is less discussed, and it's the one that explains the specific quality of fear that darkness produces. The thing that makes it different from other kinds of fear. Your brain begins to generate threats, not in a pathological way. in a functional way. When the visual cortex is deprived of input, when there is genuinely nothing to see, it doesn't go quiet. It fills the gap with pattern-generated imagery, shapes at the edges of perception, movement in peripheral vision that isn't there. This is called pareidolia in its visual form, the brain's tendency to detect patterns, especially face-like patterns and movement, in ambiguous or absent visual data. In the dark, this system runs at full capacity. Because the evolutionary cost of missing a predator-shaped shadow was extinction, the cost of seeing a predator-shaped shadow that wasn't there was a brief adrenaline spike. The brain that generated more false positives survived, and it passed that tendency to you. So when you're lying in the dark and you sense something at the edge of the room, when you feel certain there's a shape in the corner that wasn't there before, you are not being irrational. You are running the exact cognitive program that kept your ancestors alive for 300,000 years. It's just that the context has changed, and the program doesn't know that. Here's the story that makes all of this concrete. In 2009, a sleep researcher named Matthew Walker, who would later become known for his work on sleep science at UC Berkeley, was reviewing data from a series of studies on nighttime cortisol levels in healthy adults. Cortisol is a stress hormone. Its levels follow a circadian rhythm, rising in the morning to promote alertness and declining through the day toward sleep. Except in one condition. Walker's data showed a consistent secondary cortisol spike in participants between approximately 2 and 4 a.m. Not every night, but significantly more often than chance would predict. The spike was not large. It wasn't a panic response. It was a mild elevation, the kind associated with low-level alertness and threat monitoring, and it correlated with something specific in the sleep architecture data. The spike occurred most frequently during transitions out of deep sleep, the moments when the sleeping brain surfaced briefly toward lighter sleep stages before descending again. Walker's interpretation: the human brain, even in sleep, maintains a low-level threat monitoring cycle. At regular intervals through the night, roughly every 90 minutes, aligned with sleep cycle transitions, the brain briefly increases its vigilance, checks the environment, listens, and does this most intensely in the hours of deepest darkness. Not because there's anything to hear, because there might be. The guard that your ancestors posted at the edge of the fire circle didn't go off duty when they fell asleep. It just went internal. It's still posting guard in you. Every night, in the hours before dawn, you've probably felt it. The 3 a.m. awakening. The sudden alertness with no apparent cause. The few minutes of heightened awareness before sleep reclaims you. That's not insomnia. That's the most ancient survival system in your body doing exactly what it was built to do. So why does modern life not fix this? You have electric lights, you have locked doors, you have alarm systems and reinforced windows, and the complete absence of large predators in most American neighborhoods. The rational case for fear of the dark in 2025 is essentially zero. And yet the fear persists, in children and adults, across cultures, across socioeconomic levels, across people who know, consciously, intellectually, that there is nothing in the dark that wasn't there in the light. The answer comes from a principle in evolutionary psychology called the mismatch hypothesis. The human brain was built for an environment that no longer exists. Its threat detection systems were calibrated over hundreds of thousands of years of a specific kind of life, in small groups, on open landscapes, with real predators and real darkness and real consequences for getting it wrong. That environment is gone. The brain is not. Evolution does not move at the speed of culture. The architecture of your threat detection system is essentially the same as it was 50,000 years ago. The world it was built for has changed completely. This mismatch between the brain you have and the environment you're in is the source of a significant portion of modern psychological suffering. Not just fear of the dark. Anxiety, hypervigilance, the sense that something is wrong even when everything is measurably fine. Your nervous system was not built for safety. It was built for survival, and survival required assuming danger. Safety, to the amygdala, is just a longer interval between threats. This is not a flaw. It kept your line alive for 300,000 years. But it means that simply knowing there's nothing in the dark does not make the dark feel safe. Because the system that generates the feeling doesn't have access to what you know, it only has access to what it can sense. And what it senses in darkness is the absence of information, which it interprets, as it always has, as the presence of threat. Here's what this all means. The next time you find yourself uncomfortable in the dark, the next time you reach for the light switch faster than you need to, or find yourself listening harder than the situation requires, you're not experiencing a weakness. You're experiencing the output of the most successful survival system in the history of the human species. A system so effective that it ran continuously, every night, for hundreds of thousands of years, in environments where the threats were real, where the darkness held actual danger, where the brain that stayed alert survived and the brain that relaxed didn't. That system is yours. It was given to you by every ancestor who made it through the night. And the fact that you live in a world where it fires at shadows and empty corners rather than actual predators is not a sign that it's broken. It's a sign that you live in a world your ancestors couldn't have imagined. The dark hasn't changed. You have. And somewhere in the gap between what your brain was built for and what your life actually contains, in that space where ancient systems meet modern safety, is one of the most interesting questions you can ask about what it means to be human. Not why are you afraid of the dark, but what does it say about you that you can sit in it anyway? If this is the kind of content that makes you think differently about your own mind, subscribe for new videos. There's more where this came from, and the next one goes somewhere you won't expect.